Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of predictions from simple experiments. This is standard 7.6H in the great state of Texas, and we are using item number 21 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got 200 students coming to an awards dinner, and we're just going to, for preparation, randomly survey 25 kids to try to figure out what they want, and then use that as a prediction to see what the 200 kids will want. So out of that 25, you see we've got 12 that wants beef, 8 want chicken, 5 want pasta. So we need to figure out how many of the 200 kids would want these three options, right? Let's just say we're restricted to beef, chicken, and pasta. So there's two different ways that we can figure out the numbers. And so I'll show both of them to you, and then we'll just kind of look at A, B, C, or D. So first off, probably you're thinking of a proportion, and that would work. So let's just look at our beef, right? So we could say that 12 out of 25. So that's 12 beef, 25 total. Now we've got the 200 total, and that's going to get me how many total beef we have, right? But take a look at what we have to do here. I've got to do 12 times 200, and then I've got to multiply those two together and then divide that by 25 in order to get my B isolated. So that's quite a bit of work. And I would have to do that for all of these. Just replace that 12 right here like with that 8 and replace that with that 5. So that's a lot of work. Is there an easier way to do this? Well, this is what I would do because there is an easier way. Think about this constant of proportionality, because this almost seems like a rate of change, right? So I'm thinking of y equals kx. X is our, remember, this is our independent variable. And this is what we're starting with. And so this would be the 12, the 8, or the 5, right? And then something is happening to that. That's that k. Something is happening to that. And it's then turning into this much larger dependent variable, which is over the 200. That's what we're looking for. And so what we need is to find this k, right? And we actually have that right here. So we have y equals k over x. So like, how many total students are there, right? And so how many kids want each of these meals? And so if you think about our constant of proportionality here, what's happening is that we take 200 and divide it by 25, you're going to get 8. Everything is getting 8 bigger. Because if we multiply 25 times 8, you're going to get 200. And so what happens if we just take each of these? So let's start with beef. And we just multiply it by 8. All right, we could do that. That's 96. So let's say there are 96 kids that want chicken. Let's multiply by 8. Let's get our 96 want beef. Now we're going to find the chicken. That's 64. All right, so 64. Let's write that correctly. And then we're going to get 5. 8 times 5. And that's going to be 40. So you add these up, you get you 200. But now it's easier to read some of these. And that was a lot easier than multiplying and dividing by 25. So either way, if you want to see if you can find the constant of proportionality, let's see. There are 16 kids who want a beef meal. Now we're looking at 96. So A is not working for us. 52 kids who want either chicken or pasta. Chicken or pasta, that's 40 plus 64, that's 104. Not even close. 32 more kids who want beef than chicken. So beef minus chicken. So 96 minus 64, does that equal 32? Yeah, looks pretty good. 24 more students who want pasta than chicken. So pasta, no, pasta is less than chicken. So our answer here is C.